Hello, calculus learners. My name is Nikita. I'm back at it again, helping the Gavilan Tutoring Center to teach mathematics to students. Gavilan Tutoring Center offers many wonderful opportunities for students just like you to look at various online resources that can help them with their calculus journey, because I took calculus, or I'm taking it now, and I just want to help because I know how hard it was for me to learn without any help and how helpful teachers and other tutors were. So make sure to support the Writing Center. Just drop on in there, clock in, and have fun. So today we are going to be tackling differentiation rules, explained in 7 minutes, right? So listen up, guys. First off, we have the product rule. So this is in the form of f of x times g of x, and all of this is differentiated. So the base formula for this is obviously, I don't know why I said obviously, but it's the first function times the derivative of the second, plus the second function times the derivative of the first. And an example of this would be, is if we had to find f of x as like 4x cubed plus 2, and g of x as apologies, maybe I'm a little sick. No, I'm not really sick. And g of x is 2x squared plus 1, right? So in this case, we would have 4x cubed plus 2, because that is the first function, times the derivative of the second, and g prime of x would be 4x. If you remember from my previous video, if you don't remember from my previous video, go ahead and watch it. I think you guys will enjoy it. So you multiply that by 4x, and then you add this g of x, so 2x squared plus 1, and multiply it by f prime of x. And f prime of x is equal to 12x squared. Right? And this is really it. This will be your differentiation of this product rule. This is all product rule really is. And this is going to be really useful in your calculus journey because, it's a very strong basis for differentiation, and you're going to be, it's going to be like a backbone for all your future calculus needs. Like, it's not going to be something that you could just figure out right now. So make sure to get all the help you need, and just make sure you understand the topic fully. So next rule is the quotient rule. The quotient rule, let me write it here, sorry. Got some technical difficulties. The quotient rule is basically the same as the product rule, but it has something to do with division. And it's actually a little more complicated than the product rule, whoever decided to make it that way. But this is the quotient rule. So you have the top function times the derivative of the bottom function minus the bottom function times the derivative of the top function over the bottom function squared. And the way my math teacher would help me to remember this, and if you take him, you know what I'm talking about. If you don't take him, he's a great teacher. But the way he explained it was that low d high minus high d low over low squared shall go. Boom. You have to stomp at the end to really remember it. But what I assumed it meant is that the derivative of the low function on bottom times the top function minus the derivative of the top function times the bottom function over the bottom function squared shall go. And, it's just a way to remember it. So if we use our previous example of f of x and g of x, what we have interpreted as f of x and g of x, we have 4x cubed plus 2 and 2x squared plus 1. So we have 4x cubed plus 2 times g prime of x, just 4 of x, minus g of x, 2x squared plus 1, times f prime of x, which is just 12x squared. And all of this goes over 2x squared plus 1 squared. And I forgot to mention, well, I guess it's kind of self-explanatory, but the reason you'd use these quotient rules and product rules is, well, you use the quotient rule if you can't divide the function any further, the overall function. But you'd use the product rule if you just don't want to multiply the entire function out, because it would take too long and it would be very inefficient. But this thing, that would be the correct application of the quotient rule in the f of x and g of x that we have described. So there's another rule. It is called the chain rule. And I think this is a very useful rule. And honestly, I very much like this rule. I don't know why. It seems very logical and easy to remember. So it's if you have a function f of x, if you have a function inside of another function, what do? You take the derivative of this function, the outer side, and you multiply that by the derivative of the inner function. And you do not touch this function at all. You don't. The main mistake I see people do, like my friends and classmates, is that they took the derivative of the inner function before taking the derivative of that outer function. That is kind of like the main downfall that occurred. And that's where most mistakes usually happen. So what you want to do is you want to take the derivative of the outer function and keep the inner function the same, and then you take the derivative of the inner function. So in our case, which is going to be a little complicated, we have 4x cubed plus 2, which is our outer function, and we have 2x squared plus 1. So you do 4, and then we have 2x squared plus 1 plus 2. And we want to differentiate that, right? So what do? We take the derivative of the outer function first, so this entire thing. So what do? We multiply the exponent by the coefficient and then subtract 1 from it. So we have 12 times 2x squared plus 1. Remember, do not touch the inside yet. Then you multiply this by the derivative of the inside function, which would just be 4x. And this is mostly prevalent with just regular exponent problems. Like if you get 4x squared plus 2, I don't know, like to the fifth. It doesn't really matter. You have to multiply that thing and then subtract 1 from it, right? Or like if you get an ln function, you have 2 ln of x. Or actually, no. That wouldn't make sense, but you understand where I'm going with this. Like, this is just really useful in your calculus journey because like it follows you around everywhere, and you need to know this. Like, I can't stress enough. This is like a brick that you need to place for your calculus journey to be successful, and I hope it becomes successful. And why I like it, it just seems very logical that you take the derivative of the outside, and then you multiply it by the derivative of the inside, right? So some last kind of like rules, but they're more like refreshers, is that the constant rule is that the derivative of a constant is always going to be 0, right? So it's always going to be derivative of 7, 27, 37. It's always going to be 0, right? The sum rule is that the derivative of a sum will be equal to the sum of the derivatives. And the derivative and the difference rule is the same thing, just minus instead of less, right? Right. So these are just some of the rules that you kind of need, right? And I hope you guys enjoyed this video. I will be making more videos like this. And this video kind of came at like a request. Someone approached me with this video and asked me if I could do it, and I just thought I'd help them out. So if you have any comments whatsoever, please comment on the video. Please visit the Writing Center. Please approach any one of them, or you comment on this video and just ask me what topics you'd like to get covered next. And hope you like this video. I'll see you guys later. Thank you for watching.